this is an Elastic meetup, but we are collaborating with the Code Wars Academy, which is Billy's meetup group that has been going for 3 years. Bill, thanks very much for the time slot and for sharing the meetup, the Elastic meetup, with your wider audience. Maybe you want to jump in and give us just a background and intro, and maybe tell everyone who's new to Code Wars what you guys are all about.
Absolutely, thanks, Tim. I'll do that. So we started about 3 years ago. We've got a small group of loyal people who are
I'm sorry to fill up. There we go.
We've got a small bunch that meet up every Thursday to learn how to code. Varied bunch of people from different walks of life. A lot of them are not coders as such yet, but they're in another industry, and they either seek to change the industry or want to use code within the industry that they're in. So not necessarily to change to developers, but to start to harness the power of development within their domains. So Python was an obvious language of choice to delve into this. And so we've been going through a lot of different course material, learning week by week. We've systematically kept going every Thursday for the most part for the better part of 3 years. And we've got over 1,000 members in our group. We moved online with COVID. It was a bunch of people all collecting together in our boardroom. Moving it online has been really exciting and a completely different look. And when we move back into the boardroom, I think we'll keep the online aspect. For the most part, it's quite beginner focused, but we try to spot a little bit of, throw in a little bit of extras for people who do know Python, so that everyone walks away having learned something. And the kinds of things that we cover are things like building a blog in Flask, or using Jupyter Notebook to do some basics with some AI and data analytics and things like that. And to jump all over the place with some examples of things that might be helpful. So for example, recently we built a small roster system so that we could look at randomly allocating staff to come into the office, so that we could be compliant with COVID and not have everyone in the office, and make it fair so that it's random and all of that. And then we kept going with that for a bit. So we jump all over the place, and we've got a sideline group from this group building a prototype of a product, and they're using a very real methodology. So we're going through the motions of actually building a real product, with building spec documents and looking at the architecture, and actually having things like Git in place, and having people work together in teams and build, so they get a sense of what it is like to be a developer. So got all of that going at the same time. And there's a lot of humor to be shared. We're quite a laid back, casual group, and we're open to people who don't know much or anything about coding. And we want to stay, I guess, warm and inviting for anyone who wants to jump into that. So when Tim mentioned that he wants to do a bit of a demo showing Django connecting up with Elastic, I thought it would be a fantastic idea that he suggested that we bring the groups together, so to speak. And yeah, so we're quite excited to see what you have, Tim. Just as a word of warning, this is far more prepared and presented than when I run it. Isaac normally runs the group. He's one of the visitors here now, and he's a lot more prepared than I am, but I normally wing it in my sessions. But we're quite excited to see what you have to show, and thank you for hosting us, and thank you for welcoming us.
Cool. Not a problem. So thanks, Paul. Yeah, and just to mention, so Billy has a company called Assemble, and Assemble is an Elastic partner. quite a recent addition to the Elastic Partner Network. And so would I be correct, Bill, in saying you predominantly in terms of looking at implementing Elastic as part of solutions and kind of building it into the kind of software that you guys develop?
Exactly right. So we as a company are pivoting a bit, and instead of trying to build everything ourselves from scratch, we're looking at the cloud services that are available and leveraging those services to do the heavy lifting in the solutions that we have for our clients. So Elastic is one of the forerunners of that in, from our perspective.
All right. Okay. So let's get going. I think it's 10 past, and I want to hopefully keep this to maybe 60 minutes to 90 minutes. Basically, the first agenda item of an introduction has largely been done. I just wanted to also call out that we have Alexander from our developer advocacy group, who's going to be running the first demo. So Alexander, I'll leave it to you. Where you start your demo, just to give a quick introduction about yourself and what you do for Elastic and where you're based. And I'll also go into quick, very, very brief updates in terms of Elasticsearch 7.10. This landed about a week and a bit ago. So that's our latest release. If you're not aware, Elastic does a release typically every 12 weeks, I think is the kind of regular cadence. They are referred to as minor releases because it's not an entire version change, so we haven't gone from 6 to 7 to 8 in the space of a year. We moved basically from I think when I started it was 7 was the first release, and we're kind of on 7.10 now. I'll take you through the highlights of that. Alex will do his demo, and then I'll do my Django APM observability demo. So very, very quickly, 3 areas. There are 3 core areas of Elasticsearch. If you're not familiar with Elasticsearch, obviously there's a stack. And the Elastic Stack is widely deployed in like over I don't know how many billion downloads. But what we've done is, as a company, we've pivoted around 3 core solutions. First being enterprise search, and then observability and security. So we're focusing tonight's demo in terms of my demo on search. My demo on observability. Alexander will be focusing on search, but there is also a security solution that's part of the Elastic Stack as well. In terms of updates for I've got the video on my side, so I'm not a little bit. So let me carry on. So in terms of search updates in 7.10, right? So we have a product called Workplace Search. Basically allows you to add a search experience to your internal workplace. Platforms like Jira, I'll put them on the left-hand side. Jira, Confluence, GitHub, Google Drive, lots of those kinds of services, up to 365 applications, like ServiceNow, SaaS applications. And what we're providing through Workplace Search is a single interface to search all of those different sources. And we've been able to, in this particular release, introduce Slack and the Salesforce. The Salesforce is more around Salesforce development, so allows developers to access Salesforce through the search environment in the sandbox. We've also implemented document level security. So obviously, when you talk about organizational security or organizational search, security and security around documents becomes quite key. So we have implemented document level security for those 4 resources, as well as search analytics. So as, let's say, the IT service manager or someone in the search space who owns search, you can now look at what's being searched for in your organization, which searches are successful, where people are looking for something and not finding anything, and you're able to kind of fine-tune the search experience from that. So that's quite a big progression. And then observability, big one that we've introduced is user experience monitoring. So there's a minor kind of screen grab that just shows part of the capability of user experience monitoring. But this is essentially the real end user experience for your website or application. This goes hand in hand with application performance management and monitoring, which is what I'll implement tonight. But essentially, this is where the rubber hits the road. So based on, you can look at things like what are your users seeing based on operating system, or based on the browser, or based on geography. So you get a real insight into user behavior. This is a monumental leap forward. for our APM that we've made this available. So even though, like I said, 7.10 is technically a minor release, we've introduced major functionality of that, and user experience monitoring is one of them, as well as synthetics, basically the ability to run through tests on the front end and essentially test what new code's going to introduce into your website's actual performance. And you can do synthetic transaction monitoring and loading, so you can really stress test your application prior to deployment. We've also, would have gone through this in the past, but we have machine learning as part of the stack. And a core tenet to that or capability is anomaly detection. So basically trying to find instances where you have more traffic than you should normally have based on the time of day, or higher CPU usage based on what's normal. And our machine learning job basically tries to find, or our machine learning capability basically tries to find anomalies using these anomaly detection jobs in your environment so that you don't have to stare at dashboards as an engineer or a developer. We've now introduced basically turnkey rules, and turnkey jobs, so you don't have to build jobs straight from scratch. So we have jobs based on the different types of things that you might want to monitor. So this is all again quite a high value add to the platform, because it just speeds up your time to adopt and to get value. We've also, this is particularly big, added multi-cloud billing. So we've introduced a Beats agent that can now gather data from your various cloud accounts and show them in a single interface in Kibana. So you now have one way to look at all of your costs around your different cloud providers. So again, quite a big differentiator. We treat this billing data like we do any other data coming from cloud platforms. So it's just another metric, and you have the same level of power and visibility and insight into it. So you now have the ability to look at your costs quite holistically without having to go into each and every single cloud provider and looking at the bill individually on all of those. Elastic security, a whole huge amount of innovation and advancement has been deployed there. So typically in the past, we've had like a Kibana query language that has been the kind of de facto way to look at the data in our Elasticsearch. But now we've deployed event correlation rules. So there's something called the event query language. It's been around for quite some time with Endgame, which is a partner that we joined forces with about 18 months ago, 12 months ago. We've now basically completely incorporated the event query language into Kibana and the Elasticsearch. So now you can correlate events across many, many different indexes in one query. So now you can start to see correlate things that are happening across different parts of your environment in your network and your hosts, and ask questions of that data that you couldn't ask before. So that's a real big enhancement. More data source integrations and data source integration enhancements. This happens all the time. Every release we add more sources that you can collect data from. Now you can collect from Zoom, for example, which is just one of those. Lots of pre-built rules. Again, we do this all the time. Every single release brings new pre-built rules. And then the major additions at the stack level, we've introduced for enterprise clients the concept of searchable snapshots. So a searchable snapshot really means that if you look at the way that Elasticsearch stores your data for resiliency and high availability as well as high performance, we always have a primary instance of the data and a replica instance. And when you ask questions of your data, that typically goes to the replica so that you're not essentially, I guess, bottlenecking and having clashes where you're putting data in and reading at the same time. So you read from the replica in a high performance, like let's say a hot node. But what we've done as the data gets older, that performance is no longer a key priority. Say your data is 6 months old, how often are you actually going to ask questions about that? Typically it's when auditors or lawyers are asking. So we've introduced the capability to take the replica of your data and stick it on a snapshot. So your primary data, where you're asking questions and you're interacting with and you're pulling information from, that's still on disk. But we've removed the replica from your disk and we've put it on a snapshot. So essentially this halves your storage footprint, and the scope here for the roadmap is quite incredible because we can now, through the development of that technology, we can start to move more and more onto snapshots. So as you go from cold into, let's say, your next level, which might be frozen, and this will be a forthcoming feature, you can then move pretty much all of your data onto snapshots, and we just keep the metadata of where we keep enough metadata to figure out how to route the query onto which snapshot the data is living in. So that can reduce your storage footprint, tenfold. So that's a big advancement as well, and this means that there's less of a cost to retaining your data for longer. So those are quite big. Sorry, that's not my demo, but let me stop sharing. And I'll ask Alexander maybe for you to take the ball, screen sharing. Sorry, taking the ball's a WebEx term. Yeah, introduce yourself and over to you.
All right, thank you, Tim. Okay, I just assume everyone can see the screen. Let's see if we can magically get it to full screen. That should probably work. So first thing, if you have any question, like interrupt me anytime, like don't wait for the end, just scream into the void and I should probably be able to hear it. That said, yeah, welcome. Welcome to Munich and my wonderful, colorful post-it board in the background. I'm Alex. I'm part of the community team within Elastic. I've been working on Elasticsearch on the code base for 6 years, and I think I've been almost 2 years with the community team now. So I've been with Elastic for a while. And if you have any Elasticsearch questions, I should be able to answer those as well. But yeah, one of the things I liked at the beginning was mainly that we said that this is kind of an introductory group, and this is also how I want to start things. I would like to talk a little bit about search. The first couple of slides will not be any Elasticsearch specific or anything specific. It's really more about like, what is search? What does it look like for the user? What does it look like for someone who's running a search engine? And before I joined Elastic, I was basically running the search engine for a B2B marketplace for hotels and restaurants, like in a specific niche and in German. So the German language is not the best one for full text search, let me put it that way. And yeah, this is how I basically got in contact with Elasticsearch and was basically blown away at the beginning how easy it was to like index our whole catalog and run searches against that. And this is how everything got started. So I basically had to make sure that we had kind of a good and well-working search engine for a user base, which has basically nothing to do with IT, right? Like our main users were people running hotels, cooks, people working in this kind of environment. And so like you had to think and test very differently than you would do when you're just running something against an IT crowd. And this is something that took us a lot of time to learn, basically. And sometimes it's not so much about the concrete technical implementation. So what's my goal today? I would like you to learn about search, what relevancy is, and the user's perspective. And like the first question I would always like to ask is like, what is the ultimate search experience? And everyone thinking about this immediately goes here, right? Like this is the ultimate search experience. Like you type in anything and it gets back the result you're most interested in. And you don't have to have anything fancy like all those enterprise forms with like 25 different fields that you have to enter. You just have this one search bar and you get all the answers you need for your daily business. And like this is the ultimate search. But while this is the Google starting page, they also have something like an advanced search, right? And that looks like this. And now we are back to those old school forms where you have to be carefully filling out certain fields in order to find the data you're searching for. So even Google cannot deliver this perfect search experience only with this single search bar. But yet we as users, we always expect this to kind of be available for any website nowadays, right? If you have a website or if you have an e-commerce shop and there's no search bar, I'm pretty sure you're not going to intend to use that one. I see there's something in the chat. Let me quickly check. That was only Samantha, right?
I'll let you know, Alex, if there's anything that comes up that you need to ask or answer.
Right. Thank you. Okay, so regarding the ultimate search experience, I think one of the secrets there is figuring out what the user actually wants to know, right? And if we take a look at a couple of examples, like this, for example, is something that is probably very common for news websites. Like you say stock crash 2008, and somehow you have to figure out that 2008 is actually a date. You type this into Google and you usually get tomorrow's temperature, right? So again, this is also a date, but in a different form. You want to know the age of Barack Obama, you kind of can type this into some search engines. Also, there are users using Google to jump to any website, right? People go to Google because they remember the domain and type in Twitter or Facebook, and they kind of expect this to be the first hit in order to get redirected. And this is a common e-commerce query, if you want, where you basically search for a couple of different things, right? Like cheap could mean that something should be on sale. Nike is a brand, red is a color, XL is a size. So you kind of can depict this query into different filters, into different fields. And at some point you figure out you're just searching for a hoodie. Maybe that's even a category. So you don't have really anything to search for in the product name or the product description. And for something like Google, this whole query intent is super generic, right? But for most of the stuff that we as developers nowadays write, you usually have a kind of common ground, if you want, or a very concrete use case. Like in my case, a couple of years ago, it was this B2B marketplace for certain products. I knew that we are only working in this niche. So you know that there are certain terms. You can deal with synonyms, and all of these kind of things get really complex if you have a very generic solution. But most of the time you have like a kind of exact use case. And many of those generic search use cases are actually specialized, like e-commerce being one of them, news being one of them, a social network being one of them, which usually deals with a lot more names. Or in the example of Twitter, when it still was 140 characters, it also had to deal with a lot of words being abbreviated because they didn't fit in a tweet otherwise. And so over time, you kind of can extract special rules for each of those use cases. And also you have different kind of usability of those search engines, right? If you think about e-commerce, like you start searching for something, like I want to buy a new TV, 50-inch in size. The way you usually go to Amazon is that you type in a first term in the search engine at the top, and then you start drilling down on the left side, right? You may want to set a certain price range. You would never type that in the top of your search box. You want to filter by a certain category. You want to filter by the ratings, things like that. And all of those kind of features are basically done as a second step, right? After the search, you kind of drill down via faceted navigation. And then as a last step, you kind of select the product or the product variant in this case, where you configure which size and which resolution the whole TV should have. So the ultimate search experience from perspective of someone running a search engine actually is very different from someone using a search engine. And the same applies to Google as well. So one of the rules about search engines is that scoring is never neutral, right? Like there's always a definition of what is the most relevant document at the top. And especially for e-commerce, this definition is very, very different compared to what the user is probably searching. It might be that you want to factor in the popularity of a product. Maybe you have bought a product and put it into your warehouse and you want to make sure you sell it off. Then the popularity or how much of these products are still in stock is an important factor in order to sell your product. Profit might be an interesting thing. Like the marketplace where I was working before, we had different merchants and we had different kind of provisions from different merchants. So by default, it makes sense if there are two very similar products to score the one higher, which brings us more money, right? And this is the same approach that Amazon is probably following as well. Then you have something like availability. Like 10 years ago, when I was working at the other company, like it was not so much of an issue if an item was not on stock. You still ordered it anyway. Nowadays, if you go to any e-commerce website and you see that something is not on stock, it's very unlikely that you're actually going to go ahead and order it. Also, you may want to factor in previous searches, like maybe the search terms that have been used in order to boost the query, so that previous searches are kind of factored into your current search as well. So maybe you search for a certain brand or something. Also, previous purchases might be interesting to factor them in. So if you have a history of a user and you know he tends to buy certain products of a certain category, maybe boosting those products higher in this category make a ton of sense. So, and again, this is probably not what the user wants. And this is where commercial intent or the intent of the person running a search engine compared to the intent of the person using a search engine actually might differ. And if it differs too much, people will stop using your search engine. And if you don't take care of your commercial intent, you probably don't have any money to run a search engine. So you have to be super careful of basically weighing those different experiences out. And yeah, this is the example I basically brought with us today. I want to talk about social networks. So it's basically name search. And this is also where I have an example, a demo later on. And this is LinkedIn, which is easy to recognize. And I searched for Philip at the top, and you can see that there are different suggestions. The first are companies like Philip Morris. There's locations in there, but the interesting part are the persons, like the last 5 hits in this case. And you can see that probably the search works against the first name. The search works against the last name. Like this third hit at the bottom is where Philip is actually a last name. And it's also a prefix search because I'm also finding a Philip with a double P at the end, despite I only typed Philip with a single P. So you can basically kind of extrapolate these kind of capabilities of a search just by seeing what results are returned. Which is also interesting if you take a look at the connection level, like first or second only in this example. You can see that my first grade connections are always scored higher than my second grade connections. And what is also true is that the second grade connections are always scored higher than third degree connections within LinkedIn, which kind of makes sense, right? You usually try to search in or around your network, and you don't want to search for people you really don't know at all. If you do, you usually know the exact name. And there's one special feature. So I played a little bit around with the LinkedIn search so that we can basically rebuild this kind of search in a second with the different capabilities. And one of the things in there is that if you search for Felix, which is a rather common name, at least in Europe, you see that there's a couple of hits, but the first hit is actually a user with a surname, which is not part of my direct connections. So what basically seems to happen here is that the surname is considered much more important than the first name. That probably is just a feature of full text search, the terms which are less often, and Felix as a surname is much less often than a first name, are just scored higher. But it still is a capability or property of a search engine in this case. So let's try to build such a person search using Elasticsearch. Tim already introduced pretty much everything regarding the latest solutions, so I will not going to go and repeat that. The part that I'm going to use today is Elasticsearch to store and search the data against, and Kibana. And I have a super small self-written JavaScript app that uses Svelte on the browser side to execute the searches. Everything of that runs locally because the app is basically querying Elasticsearch directly, which is something you should never do in production. But for the sake of demoing, I pretty much just created the most minimum viable product, which works. Okay, the quick introduction into Elasticsearch is basically that Elasticsearch is a search engine. You can kind of cover different search use cases with this one. The most common one probably is the FTS, the full text search. This is what you do with Google basically as well. You type in a term and you get back the documents, or on the Google side, the websites where this term is included. The next part is the kind of analytics step. So instead of focusing on single documents that are being returned, you do some operations with those documents, like probably just counting them. How many documents are in category A, category B, and C? These kind of things, or how many documents have been created yesterday and the day before and the day last week, these kind of things. So just grouping things together and doing something with these counts. This is basically how Kibana works. The whole dashboarding and visualization part is using analytics and aggregations. And the last part is geo-based search. You can think here of something like Uber or Yelp. When you search in Yelp for a restaurant within 500 meters, this is basically a geo-based query where your location is the center and you kind of get all the documents which are around you. So these are the kind of different searches which you can also combine together. all of this is near real time, which basically means the time between adding new data and making it available for search should be as small as possible. Elasticsearch is distributed. That basically means that it can run on a single node, but it can also form a cluster of 1, 10, 100 nodes, depending on what your data needs is. And on the outside, you should basically you should not care if it's only 1 node or 100 nodes. If you execute a query, all you're interested in is that the results are returned as fast as possible. And if it's a cluster, like it doesn't really matter. It's only important, or it's an implementation detail if you want from a user perspective. It's scalable. You can scale up by buying faster, bigger hardware. You can also scale out by adding nodes to a cluster. It's highly available. Of course, if you add more nodes, it's likely that a single node can fail. But the whole idea of this is that because you have a cluster, it doesn't really matter from a cluster perspective. If a single node fails, Elasticsearch figures out automatically that this node is gone and tries to make sure that the copy of the data is going to be available somewhere else, so that you can basically keep doing the things without having to manually intervene and reconfigure your cluster or anything like that. The interface is HTTP and JSON. The reason for that is simple, that HTTP as a protocol is very well known. JSON as an object notation is very well known. So even if you have a new technology, you don't have to work into more than what is actually necessary. You have to understand how the query DSL works, how to send data to Elasticsearch, but at least these two common nominators are there to be easy to understand and handle with. All right, how does our social network look like? So we basically are going to index persons, and each person has a couple of fields. We just inferred the rules from LinkedIn, from the example, that we want to search in the first and the last name. We want to change the scoring or the relevancy and say that maybe if someone is working at the same employer, he's considered more important, and if it's a direct contact. And of course, you always have some meta information like the title or the image or something like that. And this is basically how our sample data looks like. You can see here that's for me, first name, last name is in there, the employer, the title, the image is just I have 3 sample images named 1, 2, 3, really being creative there. But the other interesting part is the contacts, which is basically a list of IDs to the direct contact that I have. So in this example, it would be 3, and coincidentally, every one of them is seemingly named Philip. All right, so let's try to get the demo up and running. Let me make this a little bit bigger. Whoops, sorry for that. I do have this example, and this is my sample application. We can basically just take a look at the app itself. The app itself consists of 3 svelte components. One is for searching, one is for displaying a user, and the last one is the app. And I think the most interesting part here is basically a bunch of users that get indexed, and they get indexed automatically. So if we go back to the browser and we start our application, the first thing that we see is that there's no data. I should probably make this a little bit bigger this way. And you can click on admin, and I can just re-index the data. So this indexes a couple of documents. We can take a look in Kibana and now how this looks like. Again, let's make this bigger. And now there's a social network index. And taking a look at a single document, that one here, that is me. That's basically the same document that I just showed, and there are a couple of other documents, and you can see here it has an ID, and those IDs basically exist as other documents, and we will see in a second why that is useful and needed, because we need this in order to score the own contacts higher. So now going back to this application, you can basically just see your profile. This is basically an own widget. This is the card svelte file. You can see your own contacts. You can see I have 3 of those. And again, all of this is just querying Elasticsearch. But the most interesting part is basically the person search. So I can just type something in, and for debugging purposes, I can just show the query over here. So when I search for Philip, basically this query gets sent, and you could take this query as is, and you could also put it into Kibana now and see it running, and you can see, okay, this is the data that gets returned, and the information from this search response basically gets rendered on this website. And you can also see here, like, this is a really simple query. We're only searching the first name. We are not even searching the last name. So this is not a really good or powerful query or anything like that. So I have a couple of other examples just to give everyone a feel of how different queries could look like. So what we can do next is we could try to score differently, right? This is what I was talking about with relevancy earlier. If we want to make sure that certain conditions are given, or if we want to make sure that some documents are considered more important than others, we have to specify this as part of our query. And in this example, you can see here that I basically I'm still searching only for the first name, but there's a second part of the query, and this is where search engines are starting to beginning to be different than regular data stores, where you can basically just query for things, and a result is either inside or outside of your document set. But with a search engine, it's different because you can score documents. You can kind of configure that you want to make sure that certain documents are more important if they are within your results. And this is exactly what happens here. So what we do here is that we are basically looking up the document for myself, because I just consider that I'm logged into this application. We look in the contacts field, and if the user ID in there, the underscore ID, is in here, this document should be considered more important. So when I run this, the Philip with 2 P's, you can see here that those 2 persons are direct contacts from myself, and they are basically scored higher. I marked the direct contact with a red border here instead of a gray one. I suppose it's rather hard to see, but this is the idea. And those 2 contacts are direct contacts, and they are suddenly scored much higher. You can see the score value here, because I basically configured it as part of the query. And this is kind of the whole gist of a full text search, right? You can write a super short query that returns some data, but the moment you're really interested in returning relevant data or data that follows certain principles regarding scoring, your query will become inevitably longer. And we do see this when we now basically do another kind of query where we want to search in the first and in the last name, and we want to score the own contacts higher. So now we could also search for credible, which was one of my contacts. Or we could again search for Philip with a double P. And you can see now we're not only searching the first name, we're also searching the last name. And there's another user who has Philip in his last name, which is not a direct contact. And that one is scored higher than both of my direct contacts. And then there are the other 2 ones. So this is the moment in time where, regarding relevancy, you basically need to think about different criteria. Is it really the way that I don't want to score my direct contacts higher, or maybe I do want to do that? And this is the moment where you have to think about something called boosting. Boosting allows you to kind of hand out different weights when you execute a search. So in this example, we can basically go to our next step, where we want to search in the first and last name, but we also want to make sure that direct colleagues are scored higher. So when we execute this query, what basically happens is that in this part of the query, where we define the rules for documents that should be considered more important, we add a second query that scores the employer that I'm working at higher. So whenever we find another document from our users, it will basically be boosted as well. And the result of this is that Philip Kren, who is a colleague of mine at Elastic, has now a higher score than Felix Philip, because Philip is basically matching those 2 queries. And this gets a higher score, right? He's one of my direct contacts, and he works at Elastic, so he basically gets boosted higher. we can go on here and basically change one more behavior. The rest is kind of similar. And that is that we allow for partial matching, right? This was one of the things at the beginning when I showed the screenshot, that if I type Philip, we also saw all the Philips with a double P at the end, because this is a so-called prefix search. And if we do want to have this feature as well, we can basically use something called a feature called search as you type. And executing the search, you can see here I'm now searching in different fields. And that requires some explanation. But if you take a look at the search results, you see that this is now a full-blown prefix search. And apparently, the whole data set pretty much only consists with people with Philip in their name, except for myself. But this basically makes the difference. And if we take a look at this query, I already talked about the should clause, but now the must clause has changed. And search as you type allows you basically to implement the feature, to implement this kind of search as you type features, which are insanely important nowadays. And this is not only for something like a social network. This is pretty much for everything you type, because again, the way how people are searching has changed dramatically, right? Since we all have those tiny little phones in our pockets, like, people just type something and they don't want to type something until it's done. They want to get suggestions after they have typed the first 3 letters of a word. And on top of that, we have to take typos into account, right? The likelihood of fat fingering on my phone and hitting the wrong key is much higher than typing the wrong key. And this, I suppose it doesn't only apply to me, but to many, many other people. So if you want to build a search engine for users with a high mobile user base, you have to make sure you take typos into account, or you suggest words early so that users pick the right words, so that your search gets better and uses already corrected words. And this is an important feature as well. So let's probably just copy and paste this over to Kibana. As you can see here, it basically returns the same data. But the interesting part is I'm searching in different fields. And this is another thing that is really important for full text search. Basically, full text search means that you have, or any search engine stores the data in something called an inverted index. And an inverted index is basically exactly the same as an index in a book, right? At the end of every book, you basically have a list of terms, and the list of terms refers to a page. And in an inverted index for a search engine, it's not a page it refers to so-called document ID. And the way this inverted index is structured, the way how the terms are stored in there, basically decides about the quality of your search engine. And this is stored in something called a mapping in Elasticsearch. And a mapping is kind of a rule set how data is written to the inverted index. And for the name field, for the name first field, and for the name full and the name last field, you basically have a dedicated type called search as you type. And this not only stores a term like Philip in the inverted index, which you could search for, it also stores a term like Phil. So when I just type Phil, I already get the suggestions what else or how many terms are basically starting with this, right? So if I just type Phil in here, you see that I still get all the same documents back as if I would have typed Philip. And this is the way this is stored is so important, because this is what keeps searches fast. I could also go through this inverted index and just search for PHIL and then check out every term that is in there and walk through this step by step. But in a big data structure, if you have indexed like billions of documents, this approach suddenly gets slow. Whereas just looking something up like this, the whole term, is a really fast operation. So the main thing here, I want to make sure everyone is aware, like, you can create a simple search without a lot of configuration within Elasticsearch and get up and running and have a query like the one I showed in the beginning up and running really, really fast. But the moment you want to think about how search works and you want to make sure that search is becoming more powerful step by step is where you have to think about how to write your queries, and suddenly your queries are becoming much longer. And you also have to think about how to store your data so that you can use this kind of efficient and different queries. And this is absolutely crucial. So do not kind of mix a good getting started experience with going to production immediately, but kind of sit down and think about how your search should look like. What can I do to store the data? What kind of features do I have within the Elastic Stack in order to solve a use case, instead of probably trying to solve it myself on the client side or anything like that. All right, if you want to reproduce this, I basically have this whole application in a GitHub repository. I can just dump that into the chat if you want. I will also share the presentation later on, of course. And all you need is basically a local NPM installation, install the dependencies, create a static build or run a development build, and that's it. And of course, you need to have Elasticsearch and Kibana, or only Elasticsearch installed locally. Again, it's just downloading a single file. You don't need anything else installed. Elasticsearch ships, which is with its own JDK. Kibana ships with its own Node.js version, which is architecture dependent, which also means you just have to make sure you're downloading it for your correct operating system. And that's pretty much about it to get up and running and see how this works. Everything else can basically just be done within the app. Okay, let's do a quick summary so that Tim also has some time to talk about APM and Python. Yeah, coming up with a simple query is easy. The hard part is usually figuring out what the user wants. And this part gets harder the less IT experienced your users are. It's sometimes really hard figuring out what users do. Like at my previous company, at some point, we implemented a search as you type feature, which was really, really fast, like only needing a millisecond to reply. And I was really proud of what I built. And then we kind of tested this in front of users. And we figured out that if someone is typing on the keyboard, they don't look up to the screen, so they never see the suggestions. And all my fancy feature was like built for nothing. So this is all part of testing and understanding how your users are basically building and using things. And it's way more important than you think. So sitting down, like trying to figure out or trying to ask users how they approach a problem, especially users from a certain domain, is just extremely crucial. Yeah, coming up with a proper query will take time and a lot of tries. You saw already that like I started with a small query and it went bigger and bigger and bigger and bigger to cover all the features. So it just takes time. You don't wake up in the morning and you kind of figure out the best queries. And the other part is always think about analytics and metrics, right? Like how do you measure if your query is good? It's not just how fast your query is. That's only a really tiny proportion of what is important. But like if you're running an e-commerce site and the user clicks on the first hit and it never pages to the second page, does it mean that your results are really, really good? Or maybe is the button for the next page carefully hidden? Maybe the user is just closing your tab. These kind of things are absolutely crucial to figure out how this basically works. And the other part is always like, what can be the next steps once you came up with a query? And from an Elasticsearch perspective, there are tons of more features to basically build a more fancy search functionality. One of those is the rank feature. This basically can cover the use case I said earlier, that you want to boost the document basically on its age, for example, or on the provision you're getting from a product. And this is really, really fast. We used to have a similar feature that you could build with something called function score scripting, but this is much faster. There's also a vector data type, which allows you to create your own features and then execute a similarity search. Maybe that could be the color of a product. Maybe that could be a definition of how often a product got bought together with something else. So it's just a vector and you have to define some features. And of course, like just leave this as a question, like when you build a search engine, one of the things you should always ask yourself, like, can you quantify the search experience? Like this is insanely hard, especially if you change a lot of things at the same time. Like this is one of the worst things that you can do. Like you change your search engine and at the same time you're running a big sale. Like where did your increased conversion rate come from? Like because you fixed the search or because of the sale and like all of your products are only half the price, right? So sometimes it's really, really hard and you have to make sure like if you run experiments, that you can measure them. And this brings us to the last part, like how to measure improvements. Like you change the part of your search and suddenly like your conversion is much higher, or you figure out that users stop paging to the second page of your results. That probably is a really, really good thing. Or the search is so bad that no one is actually opening any product anymore, right? And you have to make sure that you gather this information and that you kind of feed it back, or that you create reports out of that. And that is really important. So you have to log every search, all the terms, how many documents have been returned. Like at my previous company, we had kind of a search middleware that basically allowed us to see a report every morning, like what was the top 10 terms or top 10 search terms that didn't return any result. And then you could decide, do I build a landing page for this? Or do I figure out that I configure a certain synonym and fix it on that side? So these kind of things are always important to get measured. And if you want to, or if you figure out a way to do this kind of automatically, creating synonyms or figuring out the worst search terms and creating a landing page for that, you can also like go there and create a kind of automatic feedback loop. But I think this is something that takes years to accomplish, and I would try to stay away from that at the beginning. All right, one other thing, like one of the products that are part of the Elastic, or that I built on top of the Elastic stack, the Elasticsearch, is kind of covering one of these use cases where you basically have also a decent UI to configure things like synonyms or ranking or weighting or boosting. There are certain things where it doesn't delve as deep from a feature set, but it's usually a good way to get started with App Search. And you always have the full power of Elasticsearch underneath if you want to execute more complex queries. So that might be something you may want to take a look at as well. That's it. Yeah, I will share the presentation later on. I carefully hit a couple of links in here for all the documentation if you want to know more, like about the search as your type feature that I talked about at the beginning. You're here. If you have questions, you can also put those in our Discuss forum and ask over there. And with that, I will probably try to stop screen sharing if I find the controls.
Thanks, Alex. That's really awesome. I'm pretty blown away. I think if I had seen that demo in the beginning of Engineer 1, it wouldn't have taken me so long to understand query DSL and the concepts, and yeah, how to write, how to speak in JSON, which was always my biggest challenge when trying to learn Elasticsearch.
Yeah, writing queries in JSON is a blessing and a curse in the exact same second. I agree, especially if you're coming from the SQL world.
Exactly. Yeah, exactly. So that was fantastic. Thank you very much. I hope that what I'm about to share is equally as insightful. So yeah, so does anyone have any questions? I think Isaac, it seems like you wanted to ask something. I don't know if you...
Yeah, there was a direct... Go ahead. Sorry.
Yeah, I did have a question. I was in the middle of typing it out, but I'll just ask it now that you give me the opportunity. Hi there, Alex. I just wanted to find out in terms of, you mentioned the scenario of a typo. I was just interested in that situation, what does the algorithm do? Does it now change the search result in terms of popularity and then rank them according to that?
All right, so
I was just intrigued with what does it do in terms of that? Yeah.
Yeah, I will just explain what you can do with Elasticsearch, and then I will explain what you should do in your app, because you need to combine everything. So what you can do, what I have not done here, is that you can change your query to take typos into account by configuring something called fuzziness, which basically configures a parameter to say, I'm willing for every search time that I put into my search that this number of letters may be wrong. Like this would be this with an A instead of an I in between or something like that. And then the search would still work and return documents. However, because of this one term, you get much more documents back that are probably not wanted. And what I would always try to do from a search engine perspective is to try to get the user to write the first query, to write the correct query, right? So if the user types a query with 5 typos, maybe you have the ability by using something like search as you type to suggest them better alternatives, and he kind of selects them. So suddenly you're searching for a term that doesn't have a typo anymore. And this will yield way better hits in your search responses. And if you have kind of in the UI where you can incorporate that, I would always go that route instead of trying to search with something like fuzziness. Or, for example, in the example of this name burst engine, you can also do things like phonetic search. I think the most common algorithm for that is probably Soundex in the SQL world, where you basically search for terms that are phonetically similar, but you don't take typos into account. So it might be that a surname has 3 different letters. So the common example here is that for the German surname Meyer, they are like these kind of, oh, sorry, I wrote this as a private message to Billy. Let me fix that, 1 second. So if you look in the chat, we have these many different ways of writing Meyer in German as a surname. And with a phonetic search, you could probably be able to find all of them, even if you type it in the wrong way. So dealing with typos, depending on the use case, also requires you to kind of approach different strategies. And my personal preferred one is always try to get the user to search for a term that really exists in your inverted index.
Okay, so suggestions. Because I was always curious if a typo, so you can have typos where they obviously incorrectly misspell a certain word. But what happens when a typo is, for instance, it's a typo, but it's still an English word or whatever language they're using to search? I was always curious in that. Is it a matter of now it tries finds the most common, or it still finds?
It still finds even words that I mean, as the moment you index something, it's made available to search, and the search engine doesn't really have an English language model. It just finds the terms which are in the inverted index. So by default, it's returned, and then you can do things like scoring those things higher that the user really typed for with a should query I presented. And this way you could create a kind of additional ranking on top of the one that just says, this is a match I just found in the inverted index and this is not.
Sweet. Thanks, Alex.
Billy, you wrote me a private message. I'm not sure if that was just private or not.
No, it was meant for everyone, but okay. I think you did cover it in your last few slides, but I would find you unpacking it a bit more. So what I asked was, is there a way to build some search test cases to check your searches? And in the same way that you would write some unit tests for code, or some usability tests where you have a script that runs through things, is there something that works with search so that you can test outcomes against what should be predictable, and then you measure that?
So the short version is, it is possible. I know people who do this for their data set, but the advantage of their data set is that it doesn't change very fast. Like one of the companies I know is that it's a bad example for this year, but they offer holiday flats. And they're a merchant for holiday flats, and they basically have a rather static data set usually, right? You have the same amount of flats, they don't change, you add a couple of thousand or remove them, but the data set itself stays the same. And they basically use this data set, copy it into their test environment, run their queries, because they have a couple of queries where it's really important what the first hits are. Like if you search for Paris or things like that, you want to make sure that you search for Paris in France and not for Paris in the USA, which is kind of a 5,000 people village. And they do this, but if you basically have a highly changing data set, you may optimize into the wrong direction. So that's the moment you need to be super careful with that and automated test it, because this means you need to keep running this against your fresh data set, and you can't copy it over and check it into your version control or anything like that.
Yeah, no, it makes sense. Okay, thank you.
All right. Okay, I think I've stolen enough of Tim's time, so now you just need to speak fast. That's fine.
No, to be honest, I think I'm going to be an anticlimax. But thank you very much. That was great, Alex. I think that there's so much to learn around this debate, the core search functionality, the way that we index documents, the way that we tokenize and stem words, and store one word in many different ways that it can be searched more quickly. It's really fascinating. We often overlook that with what we call our 3+1 strategy, which is pretty much, as a solutions architect, I speak about 3+1 or at least 2 of the 3+1 pretty much all day long, and very seldom do we dive into the actual real core capabilities of the stack. So it's always good to go to dive in there, Alex. So thank you very much. I'm going to try and land the plane by 7:30. So in doing that, I'm going to reorder somewhat. Quickly, what I wanted to take you through was in terms of my demo, we're going to be working on just a local VirtualBox virtual machine, just much easier than engaging with the cloud platform because it's all local. I'll be setting up a Django or Python Django environment on there. It's running at the moment already just to save us time. I've also done it on a Ubuntu desktop. It's easier to follow along visually because it's on the desktop rather than showing you commands and Nano, looking at documents in for configuration files in Nano. So that's why I've chosen Ubuntu desktop, and then Django. Django is a very, very straightforward, I say very straightforward, I probably undersell it, but it's a framework that is a very easy and fast way to learn and deploy Python-based websites. It follows not MVC, but it's model template for you. So typically you define your data model within your model area, within your model capabilities. You define the templates in terms of what is actually presented to your end user, and then the view is really where the logic happens. So what do I do with inputs from the user? Where do I control security? Things like that. Django is pretty much, it's like everything in Python. There's a library for whatever challenge or problem you're trying to solve. So I don't know if it's the best. I don't think it's the most portable. I think in terms of the microservice architecture that everyone seems to be moving towards, I don't know if it's the best suited for that, but it's dead easy to do demos on. So that's also supported by Elastic APM. So that's why I've chosen that. And then Elastic. So, obviously it's an Elastic meetup, but the whole point is to see how easy it is to implement Elastic APM and get visibility into an application using Elastic, and specifically Elastic Cloud. And this is the one thing I'm running my site locally because I don't feel like SSHing into a terminal in a cloud provider. I just want to work on it globally because that's easier. But to be honest, with Elastic, it's much easier to work on Elastic Cloud because it's a SaaS and it just makes sense. Like disclaimer, this is not a best practice guide. This is just a demo, okay? So there are certain things here that I wouldn't recommend doing in a production environment. Sorry, I escaped out of that too quickly. So where do we begin? So we've got the VM, we're running Python, I've got a running Django app. What am I going to do in the demo? I'm going to build a cluster on Elastic Cloud. I'm going to start to send metrics from the VM, logs from the VM. I'm going to implement APM, so I'm going to gather metrics from Python and also implement transaction tracing, distributed transaction tracing. I'm going to set up an APM server and I'm going to send data to that APM server, and then I'm going to visualize that data. And I won't focus, I think there'll be other demos maybe next year. We will focus on actually what can APM do for you. The point that I want to get across is just if you're sitting with an application, even sitting locally in a dev environment, and you want to make your dev experience and troubleshooting a lot easier, it's so easy to do this using Elasticsearch. And everything that I'm doing in cloud, you can all do this locally. I mean, Alex in his demo showed, like literally it's a couple of tar files or depending on your operating system, download, run Elasticsearch locally and run Kibana. You can do that too. But let me just go forward on the steps here. So there is a site, it's running. I'll walk through it quickly and then I'll build a cloud cluster. I'll deploy FileBeat, I'll deploy MetricBeat, I'll import the APM library into Python. I'll make a few updates to settings.py, and then I'll run my APM checks and then basically wait for the data to come through. So before I walk you through my application, I'm just going to build a new cluster. And the reason I'm doing this from scratch, I mean, I have actually got a backup running, right? Just in case this whole thing tanks, which won't be a technology problem, it'll be a TIM problem. But the reason that I want to build this from scratch is because I really feel like it's super important to land the message about how easy it is to actually start to gather data from an application and send it to a cluster. So if you haven't seen Elastic Cloud before, Basically, you can sign up for a 14-day trial at no cost on cloud.elastic.co. You can build an Elastic stack. You can use one of these templates which are optimized for our solutions, or you can choose to build a stack from scratch, or basically configure it from scratch. I've chosen to just go with a standard single node type environment, not hot, warm, not optimized for a specific use case. And I'll choose Amazon in Ireland as my provider in my region. We'll go with the latest version of Elastic, 7.10. Name, let's call it the meetup cluster. I'll then customize it. So I don't want to cost the company a lot of money, so I'm going to make it a very small single node Elasticsearch cluster. So typically this wouldn't be what you would do in production. You definitely want to split it over multiple availability zones. Also a very small instance of Kibana, but you can see that you can basically grow this to whatever your business requirements are, your system requirements. If you're on the 14-day trial, you are capped at 4 gig of RAM per node, but you can run 3 nodes. So that should give you a lot more data than 120 gigs. It gives you 120 gigs per node, but times that by 3 and then take away 1 node from the replica. You'll have a lot of data to play with. All right, so I've got APM. I'll leave that there, single node, and we'll go and create that. So that's running in the background. Let me take you through the Django application, and I'm going to need these credentials. I should reset my password. Reset it quickly. Let me download those credentials. Like I said, any kind of issues will probably be a Tim issue. So I've saved my credentials for my Elastic, my super user, Elastic user, and now I'll walk you through the Django site. The Django site is really a very straightforward, like a light learning management system. It's a place for someone to basically create courses, and then in those courses add content items, which are really just videos which are either hosted on YouTube, Vimeo, or one of the many existing video platforms. This took a minimal amount of time to build. It uses almost exclusively plugins like the form plugins, Crispy Forms, to make the forms look good. Embedding the video as a plugin or a library that you can pip, install, and refer to. It's really, really straightforward. So this is what a video looks like. You click on a link, you get prompted or challenged for a username and password. So you sign in, and then you can watch a YouTube video basically on this, and this activity gets logged as something that you've just done now. So this is all, I think this is in GMT, which is why it's 5:13 p.m. And we have catalogs. So just the theme here is that these are the YouTube channels that my kids make me watch, or rather that I make my kids watch. And these are the best videos from those YouTube channels. So basically I'll be clicking around and this stuff all goes into an activity log. You can also send a contact form request, and this is just very straightforward. So that's the application. You can see it's running on this kind of private IP range here. It's hosted on this Ubuntu VM, Ubuntu desktop VM, and the site's really encapsulated in this folder, which a lot of which gets kind of automatically created by Django. So when you are doing things, I'll just talk a little bit about Django here while I'm at it. You have something called manage.py, which is really the management layer of the whole Django implementation. So you can see it's kind of running here, but if I stop that, you start all the application by calling manage.py in Python and running that server. There's a bunch of other commands like when you are updating models in the back end of your Django application. So you're saying things like content item, content title, description, video link, etc. You're doing that in your model. When you finish your updating your models.py for a particular application within your Django site, you run a migration. You run manage py.space make migrations. It then goes and looks through any kind of changes on record, and then you can migrate, and it does all the changes on the back end for you. Django works in the concept of a project as being the holding sort of application, and then you have apps that go into that project. So, and it creates the folders structure for you, and puts a whole bunch of predefined Python files in, which just make life so much easier. So I've got a bunch of different apps in here: the accounts app, the public app, and the content app, for example. And then I've also got the config app, which kind of just holds all of my project level configuration. So I have no visibility into this site, right? So if this site was to break, or if I was to deploy some bad code, which happens more often than not, what's going to happen is it's going to come up in this kind of like streaming log view. In fact, the output here is suppressed, but like you'll see as I click around, do different things, you'll see that, okay, it shows that there's an application, a transaction that's run. So I'll click catalog and it gets tailed to the log as well. So this is the only view that I have currently into my log and into my application. So I want to change this. Okay, so I'm going to stop this server. I'm going to go and see how far I am with my cluster. So my single node cluster is available. And I just click on the open Kibana link. And this will single sign on, or sign me on using SSO from my cloud account into Kibana, basically taking my cloud account and mapping it to the Elastic user. You can get all rollback, RBAC related capabilities for cloud clusters. You create users on the fly. You can integrate with your own Microsoft Azure Active Directory, for example, using SAML. It's very easy to control and make secure. But one of the benefits of using cloud is that there's certain things that are just streamlined. I don't have to log into Kibana separately. What I do want to do is add data, because at the moment there's no data in here. So the easiest way to do that is to click on the add data link, and to tell it to basically tell Elasticsearch what data do I want to collect. So the first thing I really want to get is system logs. So let's look at logs. System logs is always hiding somewhere. I think it's in here. So yeah, the first thing I want to do here is collect these system logs. So I'll click on that. So Kibana knows I'm on a Mac, but I actually don't want the Mac files. So I'll download and install FileBeat. And now this is kind of where I constantly make mistakes, because I'll command copy and command paste in an environment that wants me to control paste rather than command. So we'll download the FileBeat package. Okay, so let's come down and unpack it. Okay, now we want to go and edit the configuration. So if you've ever done any work with FileBeat.yaml, pretty much you'll know about this, basically what the point of this all is. So this tells FileBeat basically where to look for log files. It's all kind of predefined, all set up for me. The only thing I really need to do in here is add the cloud ID so that I can authenticate while I'm sending data. I can basically get the rights to send data to the Elastic Cloud. Like I said, don't use this in production in the sense of embedding your password in a plain text in the YAML file. I need to get my password. Okay, so we'll replace that. No. This is not copy paste. Okay, so that's my Elastic password. Okay, and then I want to configure the module for system, right? So this is going to tell FileBeat that I want to enable the system module. So let me just divert slightly from the demo and say, like, let's have a look at this particular FileBeat installation. What can it actually collect? So I'm going to pass the command FileBeat modules list, and it's going to tell me that, you know, the built-in capability of FileBeat is to collect logs from all of these different services. I've actually only enabled system, right? So that's getting the Unix system or Unix system services, but I could easily enable the ability to collect the ability to collect any of these sources. So that's really useful to know. Next, we want to basically start FileBeat, but before we do that, we actually want to go and call the cluster and say, hey, listen, look out for FileBeat log data. So we run FileBeat setup. Okay, clearly this was a user issue on FileBeat Nano. I think I should probably comment those out. That's never happened before, which is really classic for a demo. I think this definitely has something to do with the fact that I could it have been that I reset the password. It seems pretty much right. What I'm going to do is I'll repaste those, and then I'll just reset the cluster password just for luck. Maybe I chose credentials for them earlier. So those are the valid credentials. Yeah. All right, that this works. That is very typical of a demo where you're running it live. So here's what I'm going to do. I'll run you through the rest of the process to set this up. So what you would do is essentially enable, you call FileBeat to go and set up the dashboards. You then tell FileBeat to start as a service, and the data should start to flow through. So then you may want to add something like metrics for the environment. So again, click Add Data and collect system metrics. And you follow basically the same process, where you pass it things like you download the metric beat, you pass it credentials, you enable and do the setup, you build the dashboards, and you start that service, and data will start to flow. Now, the real interesting thing is let's say you want to add APM data. So this is where it gets really interesting and very easy to do. So you'll see on this observability page, this is telling me like I've got no observability data, so I really can't help you at the moment. But here are the ways to get data in. So let's go to installing an agent, and we know we're running a Django application. So it's very simple. You run the pip install for APM, So you stop your service, run pip install, and then start to do things like copy the snippet of code, go on to your settings.py configuration, and start to basically update the configuration. So because you'll do a pip install, you can say, well, I want to run, I'm going to tell it that I'm running the APM app from Elastic. So you add it to installed apps. You can also then add it to your middleware, right? So you add the Elastic APM tracing middleware to the application. You then pass things about APM. So you add a whole new section in your configuration on settings.py, and you put that information in. You save that, you reset. The one thing you need to do is you need to say, because you're running a Django in debug mode, because it's essentially just running locally. Because it's running in debug mode, you need to run Elastic APM in debug mode as well. So you make those changes, you restart your server. What I'm going to do is, with the magic of having made sure that I would defend myself against any issues while we're going, is I'm going to get out of this cluster. Run my backup cluster, open up Kibana, let's run the backup VM. Let's restart this guy. Just want to make sure I get the right IP address for this. Okay, so this is my application. It's kind of basically the same IP address but different virtual machine. This is Elastic's Kibana interface. I've got the observability view, and now instead of having no data, what I'm going to have is data that's going to start coming through. So you'll see the VM was dead basically until I started it recently, so it wasn't collecting logs. But now I'm getting things about log rates. As you refresh, just basically, and as we interact with the system, we'll start to see more metrics come through. But I understand I've got logs coming in, I've got metrics coming in, that's all very easy. But what about the actual application performance? So we dive into APM. And now I'm just going to generate some data here by clicking around. With the login, why don't we just log out for good measure? Give the catalog. Well, we go to the sign up page. Just generally create some traffic here. Now, when we go and look at our APM, you'll see that when I updated my settings.py, so we can take you through that quickly. When I updated settings.py, I actually defined the service name. So I said it's the demo LMS Lite. I passed the secret token for the APM server. I pointed this straight at my APM server and I said debug is true. So start collecting information for me, even though I'm in debug mode. So we're going to have a look at the service. Now, if you were in a microservices environment, you would see that there would be many services that would be basically collecting information. But now, and it's all down to the fact that I haven't really created a lot of traffic on here, that what you'll start to see is that data is going to start coming through for the application. So you're going to see time spent on average transaction time, the number of requests per minute, time spent by span types. This is interesting. So you can see how much of it is the actual application, how much of it is Django, and how much of it is the call to SQLite. And I'm also going to start to see things like the actual API calls from my application to the Django core framework. So it's obviously doing static image serving and content serving. So I can click on that transaction. And now I can see, well, on average, this takes around 350 to 400 milliseconds. per transaction. It sometimes takes up to a whole second. And this is the process flow of those steps. I can look at logs and metrics that are related to those transactions, which is very useful. So I can contextually now look at information about the virtual machine running my application. But I can also look and see, well, there's a real problem here, or not a problem, but I mean, naturally, my static objects within my Django site are taking the longest to load. Login and log out potentially, or getting the login form and posting the login form is taking the second longest on average, etc. If you're in a dev environment, if you're looking at rolling new code and you want to see errors, we're going to pick up errors from the Django logs in here. So if there's when Django throws an error, it's basically like it's anyone's guess when you first look at it, right? So it's very good at making it very difficult to troubleshoot. But we're able to basically give you a better interface to look at those errors. And you can also just see the general metrics of the application from the system and memory usage point of view. The service map is less impressive. The main reason being is we've only got one service. But if we're running a microservices environment, or I had a separate SQL service that I was doing APM on, I would be able to see the map between this application and any dependent applications that I have. Adding data contextually within Kibana is much easier now than it ever used to be. So from a dashboard, you can add data, again, different types of collectors, even real user monitoring agents now. And yeah, and if you want to know about PHP, which I think a lot of people always ask me, it is on the roadmap. So we are working on that. And then pretty much that would be the extent of what I wanted to show you, just going from having a completely unmonitored and unmanaged application. Granted, I had a bit of a hiccup in the way, but the principle applies no matter what, because I've run through this a few times and really it's very straightforward. And as you click around, as I generate traffic, you'll start to see more and more information coming through into Elastic, giving more insight into my application. Cool, I don't see any, I'm not really looking at the chat, quite frankly. Let me see if there's one question. Oh, that was just Alex putting the slides up. Yeah, that's really it from me. Thanks very much for bearing with us. I think we're 3 minutes over. Alex, thanks a lot for your time, and Bill for lending us your time slot and your group. I hope it is valuable to everyone, and yeah, reach out to me directly if you need anything. I am essentially architect that looks after Africa and South Africa. Something that's probably very relevant is these dashboards that are like kind of pre-built and predefined. These come out of the box. It's very important to note that they work exclusively when you align your data schema with Elastic Common Schema. So where you have essentially parity of fields and naming conventions across multiple indexes, because something like this dashboard, for example, is getting data from many indexes. It's getting it from the metrics, from metric beat, file beat, APM indexes, etc. And it's presenting it in one view. It wouldn't be able to do that if it wasn't aligned to a common schema. So really, when you go to a common schema with Elasticsearch, it makes a huge difference, and you can get a lot of value correlating between different indexes within your environment. But yeah, that's it from my portion. That's also the last meetup for the year. I think everyone's very tired of Zoom calls. I don't know if we've managed to keep most people on the call. I'm personally very, very tired of Zoom, so we're not going to have a meetup in December, but hopefully in January things we'll be looking at when we can do something in person, potentially. I don't want to make promises, but thanks everyone. It's been fun.
Yeah, thanks guys. Thank you, Tim, and thank you, Alex. That was very, very enlightening. I can vouch for Tim's code actually working because we did the dry run and I saw results. So I'm not sure what the difference was, but thank you, Tim, for all the effort you've put into that. Very, very interesting stuff. I'm hoping that this has sparked some exciting ideas and everyone watching. To the Python meetup, this isn't our last one for the year, so we'll see you guys next Thursday and the Thursday after, and we'll hop back onto the Python stuff. If anyone is interested in tagging along on some of our meetups, contact Tim, he'll give you the details. Anyone from our meetup tagging along with future Elastic meetups, pop me a message and I'll hook you up and get you on that meetup. I think this cross-pollination thing has been absolutely fantastic, and I'm hoping we do it again soon. Maybe because we're working on a Flask project, maybe we can make one of the checklist items on our project to hook the Flask app that we build into Elastic, so that we can look at the metrics and all of that sort of stuff. So Tim, we might be calling you back to just show us some alternative flavors to what you've shown us. But thank you for your time. We won't keep you guys any longer, but really appreciate it, and have a great evening and be safe for the rest of the year.